So we seem to be having a few more people trickling into the webinar now. So now is probably as good a time as any to start. I'm sure we'll have a couple more joining as we go on, but if we kick off now, and as people join, they'll be able to continue from wherever they're able to join. So good morning to everyone who's able to join us so far, and a very warm welcome to our webinar for today, which is all about keeping business connected when it matters, and that's by preventing single points of failure. So today you can see my mugshot up there on the screen. My name's Scott Green. I'm a senior account manager here at Prosperon Networks, and I'm joined today by Dave Spence, who is senior pre-sales engineer at NetBrain. So we are here to help give you a better understanding of the opportunity of network automation as it relates to network intent for critical link failovers to ensure they're configured correctly and always to prevent outages. So that's just a very quick introduction for you all. I wanted to briefly take you through who we are as Prosperon Networks, and then we'll move on into the actual presentation and webinar. So at a glance, some of you may be new to us today, and some of you are probably familiar with us. We are typically known as the leading UK authority on deploying, tuning, and training users of SolarWinds products. So you'll see on the screen here that there are some things that we're really proud of. Over the last 16 years, we've worked with SolarWinds as a partner. Now, whilst for many of you, this will maybe be the main reason why you know of us and the main interactions we've had so far, as you can see around the professional services, support cases around SolarWinds, one of the things we do is we also work with other vendors who we see as being complementary and adding capabilities to that SolarWinds product suite. And one of those vendors is NetBrain. Now, we've held webinars before with NetBrain, and you're welcome to look at those on our YouTube channel, which I'll be showing and giving the link for later. But today we're going to focus on the ensuring critical links are configured properly for failover to prevent outages, and that's using network automation and network intent with NetBrain. So that's the purpose of today, to show you how NetBrain can add that capability to your existing SolarWinds product suite. So why should you care? So simply putting a backup or disaster recovery plan in place is no longer really enough. I mean, let's face it, if it can fail, it probably will, and most likely when you're least expecting it. The main reason is because configurations change and sometimes drift away from the architect's original design intentions. So this is due in part to the manual nature of network operations work. And I'm sure you're all familiar with this, but Gartner states that approximately 70% of network configuration activities, like changes, associated pre-changes, post-change activities, are usually manually driven. So this leads to configuration drift, as many manual changes are unplanned and undocumented and often aren't cleaned up after the fact. So in the real world, a simple link failure can result in a catastrophic outage, and this, of course, due to that drift in the original network design causing problems with the expected failover protection. So if someone hasn't properly configured the backup link, it can prevent communication altogether, or it performs far outside the needs of the critical link design. So the backup link is your last line of defense from a blackout, so it must be functional even when it's not in use. So another stat from Gartner, they state that technical entropy, specifically configuration drift, is the primary contributor to networking technical debt. For example, when branch routers were first deployed, each device had an average of 200 configuration lines. With time, as network teams have added new features and changed quality of service and security policies, there are now more than 450 configuration lines per device. This occurs during troubleshooting and as new applications and requirements are layered onto the network. As a result, they predict that by the end of 2025, 30% of enterprises will establish new roles focused on IT resilience and boost end-to-end reliability, tolerability, and recoverability by at least 45%. But what's interesting here is we're talking about day 2 operations. So day 2 operations being that big chunk of time that happens after you provision and configure the network. And we truly feel that this is an area where we can help NetOps better align with the business needs. So by establishing every network as a series of network intents, we can eliminate the device level details from the operational staff. And since this level of abstraction exists, human error and errant changes can be eliminated, since the operators and engineers are focused on the network intents, not the devices themselves. So network intents manage expected results rather than relying on traditional device level management approaches. The network intent, the intent of your live network, in addition to the associated diagnosis logic to detect deviation of those intents. So managing the network as a collection of tens of thousands of intents, not 1,000 devices, is the path to network automation. By abstracting the underlying network details, you can translate business intents into network intents and then ultimately to device configurations. By combining these network intents with automation, day two network operations become scalable, a huge value in the era of constrained skilled resource availability. So day two automated network operations allows you to manage your hybrid networking by capturing, verifying, and enforcing network design intents and eases problem diagnosis to ensure those conditions are maintained. In this way, NetBrain differs drastically from all other device-based network management approaches by focusing on application needs and services in use. NetBrain's PDAS, or short for Problem Diagnosis Automation System, manages hybrid networks as a compilation of network intents which directly supports IT service delivery needs. We can accelerate the remediation of nearly 95% of all network service tickets and eliminate up to 50% of network problems before they impact on the production network and the business it supports. So hugely powerful. And this reduces MTTR dramatically, increases uptime, and lowers operational costs. So after spending a lot of time talking to our customers, NetBrain has learned what their top 8 network challenges are for day two automation. And in response, I've created a webinar series to focus on these use cases. So today's webinar, as we stated before, is focused on how intent-based network automation helps prevent network outages due to backup link misconfigurations. The intents do the work for you, so you can focus on the more important work. They help you troubleshooting ISP infrastructure and MPLS backbones by monitoring, auditing, and checking resiliency before something happens. You can see if a standby link is missing a line of configuration, and we can constantly validate the design and report back regularly, which Dave thankfully is going to demonstrate later. You can verify the health of a link and the state of the critical application parts, including a logical check with multiple subjects for CPU, memory, latency, BGP prefix changes as an intent. And that means check that the second link is up. Does it match the active links configuration? Is the second hop reachable? And NetBrain uses probes to prevent outages and leverages your in-place network monitoring tools to trigger network intents automatically, like if there's an interface error. And it can verify compliance by checking the routing protocols are authenticated, and if your access lists are consistent and that they match certain standards. So modern networks are designed to eliminate critical link failures. The problem is that you rarely test redundancy failover processes live in production to ensure that they'll function as needed in stress conditions. Many times a catastrophic failure is the first time to realize the failover links are misconfigured. Few operations best practice include ongoing verification of standby components. You just assume that the resiliency capabilities will function as needed when it comes to it. So using NetBrain, this means you can more easily maintain compliance, improve resiliency, reduce downtime, reduce or eliminate configuration drift, and eliminate manual errors. So NetBrain prevents configuration drift from sabotaging your business continuity plan by capturing network intent embedded inside your current failover design, monitoring the design intents continuously, and warning you when detecting configuration drifts, so you can deal with them long before users begin reporting service issues or more severe consequences materialize. In a minute, Dave's going to walk us through these 4 use cases. He's going to show you how easy it is to ensure simple link failovers don't turn into catastrophic outages due to a drift in the network design that has damaged previously implemented failover protection. In the demo, you'll see how NetBrain uses intent to capture the failover design, monitor the design continuously, and warn if there is any configuration drift. Dave, if you're happy, I'll pass the presentation over to you and you can take us through the demonstration.
Thanks for that, Scott. So let me share my screen. So we want this screen here. So hopefully you should be able to see my NetBrain desktop. So yeah, so what I actually want to do, first of all, I'll introduce myself. I'm David Spence. I'm Senior Pre-Sales Engineer at NetBrain. And what I want to do is take you through a demonstration of network intent and how it can help you prevent costly outages. So in this use case, what we will look at? We'll look at how NetBrain can protect resiliency. So as Scott was mentioning this earlier, having redundant links is an important way to protect against network outages. But you also need to ensure that any failover is successful. So for example, are my ACLs consistent? Are my routing tables what I expect them to be? Is the other side of the WAN reachable? So it's no good having redundant links if one of them isn't working. So NetBrain's network intent uses automation to verify that everything is working as intended, hence the name. So if there is a failover, then it will be successful. So in this way, we can prevent an outage from occurring and we can keep our networks up, keep our networks green, if you like. So we can see here on the left, I've got a series of intents. So these can be run on demand, or they can be scheduled, or they can be triggered in the response of a particular event. So let's have a look at one of these, and let's have a look at how easy it is to create an intent. Let's pick this one. This is quite a good one. So let's go in here. So a network intent is comprised of member devices, which is over here, so we can see that the different devices. There's only 4 in this case, okay? But it's also got a series of diagnoses which we can run against them. So we can see here we're running a couple of tests here. So here, let's have a look at the top one here. So here we can see we're performing a ping on the device to the IP address at the other end of the link. But the clever bit is over here, look. Yeah. So we can see here how NetBrain is extracting the output of this command and placing it into a variable. And we can see the value of the variable here. And if you think about this, we don't have to resort to regular expressions or coding. We're just highlighting where in the output the variable we want resides. And so we can see the result here. And actually, we can get quite sophisticated with this, actually. So we can do things, for example, if you imagine things like the show interface command, well, actually, you can do that as a paragraph. Yeah, you'd add a paragraph variable. Yeah. And what about when you've got commands like show IP interface brief? For things like that, you can extract the output as a table. So you've got quite a few options here, and you can even do things like embedded paragraphs as well, depending on the command output. And if you go over here under define diagnosis, yeah, under the next tab here, we can actually have a look at how we can use this logic. And again, there's lots of different options here. And as you can see, this is not rocket science. So what we're doing here is we're taking the results of this ping command. So if we have 0 replies, we've got a problem. So we can set a red status here. Red is bad, yeah? So here, look, and we can put a message in, destination not reachable. And we can actually put variables in here as well. So we can actually indicate the result and give a little bit more information. Now we also have, if I go back, we also have a second diagnostic here. And in this case, we're checking the routing table. Again, look, we're extracting the output of a CLI command. That's our CLI command, and we're extracting the next hop here. Yeah, and we can see next hop IP is that. Yeah, but this time what we're doing here, if we go under the diagnosis, we're checking whether we've got a valid next hop for the route. So in other words, we're just verifying that the route exists in the routing table. Yeah, and actually you can see here, by doing this, you can put in multiple tests in a single network intent. And in fact, I've got 3 here actually, but actually, let me just come out with this. But actually, you could do all of this in a single intent if you really wanted to do that. I've just split it up so it's easier to see the individual results. So we've got 3 intents here. So we've got an ACL consistency check at the top. So this is all about, are my ACLs on the routers on each link consistent? And if you think about this, it would be really bad if they weren't. If you didn't have consistent ACLs, you might end up with subnets or customers who aren't reachable anymore when there's a failover. Next hop check. Yeah, so are the next hops on each link stable? So this could indicate a routing problem further downstream if they've changed. And finally, down here, we've got a reachability check. And we looked at this one in a bit more detail. So this is all about, is the end of the link at the other end of the WAN, is that reachable? So we need to have confidence in all three of these to ensure that we have network continuity if there is a failover. And there's lots of different ways of doing this and putting things like this together in lots of different orders, and different tests could have been put together. And we even have a concept of a network intent cluster, where you could create a network intent for a number of devices and then clone that across lots of different devices using different rules across your entire network. So you can get very sophisticated with these. But what I'd actually like to do at this point is actually run these. Yeah, so we can go in here, look, and I can run them. Run the first one, run the second one, and I'm going to run the third one. Yeah, and actually, if we have a quick look here, we can quickly see the results. So everything looks good. Okay, fine, nice and green. And if we, oh, and this is good because we've got a failure. So again, it's very visual. You can see instantly, there's been a failure here. And if I actually go in here, we can actually have a look. So we can see here ACL 11 of this particular router mismatches. And if you click details, it's giving you more information. So it's showing you here, look, if I just hover over here, this is really useful. It's quite visual, yeah? So you can see here, I can hold the mouse properly. ACL configurat of this router here is this, but of the other router, it's that. So they're different. My ACLs are different. So what's really important here is that we can see that the intent has failed, but better, it's telling us why it's failed. So we can clearly see here that the access lists on router 1 are not the same as the access lists on router 2. Yeah, they're not the same. So immediately we can see that we've got a problem. And when you think about this, this is really bad. So the subnets for R1 are definitely not the same here, look, as the subnets in R2. So this means that if there is a failover, we could be in real trouble. So perhaps some users or applications will no longer be available. So this is incredibly useful because it's alerting us of a potential problem. So what I want us to have a look at now is the other two intents. But again, what's good here is you've got the information here, all in the network intent, and it's showing you. And I've just run this on demand, and we'll look at this later. You don't have to run this on demand. You can run this. You could also make this whole process. But it's just useful for a webinar to actually go through this as a demonstration to show you how you do this manually. So let's have a quick look at my other network intents. So if we have a look here, next hop check, for example, so we can see that next hop is unchanged. So it's showing me here that it's actually, again, the value is current, and it's actually showing me that the actual current value here, look, so we've got a value, and it's actually showing me here that it actually matches the baseline. So my next hop in my routing table is nice and consistent. So this is very good. So we can see it's valid and it hasn't changed. So that's brilliant. And let's have a quick look at the reachability check at the bottom down here. So again, we can instantly see it's good because it's green. Green is good, red is bad. And again, I can go in here. Let's have a look at my pings. And again, success rate is 100%. And I can go in here and it's just showing me that. So it's saying here, look, success, it's reachable. And again, I can go here and actually have a quick look at my route. And again, details. So again, I've got a value, it's passing it, and it can actually see that it's got a next hop. Remember, this was fairly simple. This is all about, is there an entry in the routing table? And there is, so it's fine. Yeah, so that's brilliant. So we've actually verified that the route is present in the routing table, and it's all showing nicely as green. So actually what we've done here with these three network intents is we've verified three things. Are the ACLs consistent on the two routers? No, okay, no, they're not, but okay. But at least we know that, and we can fix that, okay? We also have checked, are the routes consistent across the links? And they are, that's good. And then we've checked over here, is the other side of the link reachable? And it is. And again, you could change these tests. There's always lots of different ways of doing this, depending on what you're trying to achieve. And I would argue here, very much the key thing from my experience of creating network intents is, if you like, the hard part is the actual networking knowledge. You need to know what you're doing with the network. But as you can see here, provided you know the correct commands, and you need to know what the results of those commands are, then actually you can build some very, very powerful network intents depending on what you're trying to achieve, especially if you've got problems which occur again and again and again. You can create a network intent for that so you can be alerted when that problem happens again. It's very powerful way of preventing stuff. And actually, that word prevent, let's actually move on, because yeah, we've got 2 out of 3 ain't bad, as Meatloaf would say, and that's pretty good. We're highlighted to that. But actually, what I've shown you so far has been manual. Yeah, so wouldn't this be great if we could trigger this by an event? Perhaps we knew the configurations were fine to begin with, but the reason that these ACLs over here don't match is due to configuration drift. So maybe some engineer came in, he modified the ACLs, perhaps due to a ticket, yeah, or any other event. So wouldn't it be nice if we could automatically check for these issues when an event such as a config change or perhaps an interface status change occurs? Yeah. Well, thankfully we can using NetBrain's preventative automation. So I've got a tab over here. So let's have a quick look at this. And I've actually highlighted this for one of my routers. So what we can see here are our network probes. So you could sort of think of a network probe as a mini intent. Yeah. So let's drill down here. There's one my colleague Leslie created. Let's have a look. Failover check. So let's have a look at what we're doing. So you can see it's sort of familiar again with what we saw earlier, but it's much simpler. So what we've done here, we've issued a command here. Look, we've got the show IP route, and actually this is quite clever, because what we've got here, if I go in here, you can see the input variable. So we've put in an input variable here, okay, 10.8.70.70. So it's verifying that route, and it's saying here, again, similar sort of logic to earlier. What we're doing here, we're saying if the next hop, which again this is a parser, so this is a pre-built parser, which is actually taking the next hop from the from show IP route. If it doesn't equal this particular value, then we're going to issue an alert saying route failover has occurred. Yeah, so this is very simple. And actually, if you look here, if we go back in here, look, you can see this is running every 30 minutes. And you can change this frequency as well. Yeah, and you've got a primary frequency, and you can actually specify under polling control how often you want that running. So you could have that running every 15 minutes if you wanted to. But we've got that running every 30. Okay. Now, what we can also do, and I'm going to come back to this because there's some other things here I just want to highlight. But the other thing we can do as well is look for a configuration change. So what this is all about is verifying, has the configuration changed? And if it has, then we can generate an alert for that. Yeah. But what's important here, all of these different probes, we can select different frequencies for when they're going to run, and we can send emails. You can see this here. You can specify the frequency here, look, and you can send emails. Yes. So you can send emails if basically if the condition is violated, as we saw. Yeah. But actually, what's really useful here is you can also then trigger an intent. So think of a probe, like I said, think of it as like a mini network intent. But actually, if that is then triggered, you can then actually trigger a network intent, which can dig deeper. And in fact, network intents themselves can trigger other network intents depending on the output. So you can actually have conditional logic to say, well, actually, depending on this condition, trigger this other network intent. So you can end up with this diagnosis tree. That's maybe for another day. But if you look here under triggered automation, so let's have a look. I will pick this one because it's nice and simple. So this is my configuration change. Yeah, this itself is triggering a number of network intents. So you can see the one at the top, which we talked about earlier, our old friend, the ACL consistency check network intent. So if there is a change in the configuration, we can trigger this network intent automatically, and somebody can get emailed about this. And actually, I've got an example of that email, of some of these emails here. So these are fairly old emails, which I set up some time ago when I was creating all of these type of demos. And so you can see one here. Look, there's been a flash probe. It's giving you the probe name, configuration change, and it's giving you the time as well that it was triggered. And that in turn is then triggering the network intent. So this is the network intent, which has been triggered, and it's showing me here the status code, the execution time, what it's being triggered by, the particular device. So you've got all of this information right at your fingertips. And this is magic, because if you think about this, a lot of the time, network outages are the results of things like this. Somebody has changed something, or perhaps something on the network, if you like, more dynamic, like a routing protocol has changed something. And by the way, those type of problems are really hard to spot manually. But nonetheless, the change might have no immediate effect at all. All is fine. Our network appears to be working well. But then something like a failover occurs and we're in big trouble. So by checking for events like this and then going ahead, running a network intent and digging a bit deeper, then we can hopefully prevent one of these potential outages from ever happening in the first place. So this is why we call this preventative automation, because it's looking for these, if you like, hidden, hard to spot issues, which could have potentially devastating consequences in the future. So I wanted to show you those. Right, so let's go back to my GUI. So everything we've spoken about so far is being very concerned, if you like, with traditional networking equipment, our switches, our routers, our firewalls. But what about the cloud? How can we ensure that we are, say, accessing our cloud resources by the optimal path? Are we going via MPLS or are we going, say, via the internet? So if I go over here, I've got a NetBrain map over here, okay? So this is this is a map of our demo environment in the United States. And just quickly a quick run through of what's actually on here. So again, I see this a lot with my customers that they have. Let me just zoom in a bit so you can see this a bit better. You have lots of different types of technologies. So here, look, this is a wireless branch, and you can see where the devices are connected. And then actually that itself has got to connect to the data center. So how will it do that? Well, it'll connect over the WAN, and in this case here, it's SD-WAN. And what's really good about these maps is they're dynamic maps. And as you can see, as I zoom in, we're getting more information. Okay? That's why we call them dynamic maps. And in this case, we've got Viptela. Zoom out a bit just because it's easier. And then that's going to go over to a data center. So you can see here at a data center, again, we've got our traditional networking equipment, but actually we've got some next generation firewalls here as well. And again, it's worth pausing for a second, because a lot of the time, even if you're in a traditional bricks and mortar data center, and even if you like all Cisco or all Juniper or whatever, typically you will have other vendors in there as well. So you'll have things like firewalls, which may or may not be Cisco. There might be something else, Checkpoint, Fortinet, Palo Alto, etc. And actually, if you are then serving up applications there, you're probably going to have some load balancers in there, maybe a NetScaler or an F5. So you're still going to have this multi-vendor play, even in these fairly traditional data centers. But then, and we're seeing this increasingly actually with our customers, we're seeing actually an increasing move to things like Cisco ACI, software-defined networks. And actually, I was seeing that quite a lot a few years ago, this move, and we still are, actually, it's still there. But increasingly now, we're also seeing maybe replacing this or in parallel with this, we're seeing a move to the public cloud. So in this case, what we've got over here is we've got Azure, we've got an Azure network. We've also got a network over here running in Google Cloud, another one in here in AWS with some paths, which I'm going to come back to in a second. But the key thing is, the reason I wanted to show you this and spend a little bit of time before I actually move on to the next point is that modern networks are super complicated. So actually being able to understand how my traffic moves and flows from one particular location to another, what are all of the devices which are forwarding this traffic, it's actually very difficult. There are lots of little point tools out there and things like that, but nothing which gives you this full visibility across lots of different types of technologies, and also lots of different vendors. But it's not just the different vendors, but it's the different technology types. The software defined, the public cloud, my legacy environment, my lots of different types of firewalls, and being able to look at all of that and see how all of that fits together. Very, very difficult to do, but actually it's essential. And this comes back here to what I wanted to show you. And this is if you like, I'm back on script now for the demo. So what we've got here is we've got a couple of NetBrain's A to B paths. And again, it's important to understand about NetBrain's A to B paths. They are not just simple trace routes. So they are built up through NetBrain's understanding of this network. So NetBrain will have discovered this network. NetBrain connects to the public cloud using the RESTful API. And NetBrain understands the forwarding table. So things like firewalls, for example, we will understand here exactly how. Let me just show you. We will understand on a firewall exactly if it's got things like ACLs, what it's doing. How are those ACLs dealing with that traffic. So it understands all of that. This is actually quite sophisticated for things like my public cloud resources, because we're connected to them and we're pulling the data via the RESTful API. We understand how all of that information is being forwarded and being moved. So it's incredibly powerful. This is quite sophisticated stuff, really. It's giving us quite detailed visibility here. But actually, what's useful from this point of view is that we can see these two different paths. And this one here, look, we've got a blue path and we've got a green path. Yeah. So we can see here this green one over here, look, it's going through our MPLS networks. It's going here, look, we've got this Fortinet firewall. It's going through our MPLS network, and then it's hitting this let me just zoom in a bit for you. It's hitting these DX routers. And again, as you zoom in, you can actually see that level of information here. Yeah, but for the other path, this isn't doing that. This is actually going here. If you look here, this is coming out of my network. It's coming through my Cisco router, and then it's hitting this router over here. And you've got these tunnels which are going over to this virtual private gateway in AWS. So actually, this is going through my internet VPN. But you can see that. And again, as you zoom in, look, you can see information such as VRF information, things like that. So again, tunnel information. Yeah, I can go in. Let me go in a bit further. Yeah, you're getting all of this information coming out as you zoom in. This is why these dynamic maps are incredibly useful. And again, this is important. If your company is hosting applications in the cloud, that's because they are being consumed either in their own organizations, or perhaps they're being consumed over the internet. Yeah, so they really want to know how these applications flow over the various networks and then back into the building. And we can see how easy it is to view these flows here, and it's a very visual way, which is very important. So I think that's pretty much everything I really wanted to say on all of that. And we've looked in quite a bit of depth, really, how NetBrain can check our WAN links and ensure that if there is a failover, we're not going to get any nasty surprises. But we've also looked at how NetBrain can prevent outages by automatically triggering these checks in response to something like a network change occurring. And then finally, we've shown how when using the public cloud, NetBrain can visualize the exact path taken between our on-premise equipment and our public cloud resources. Showed all of that here. So thanks for listening. I think I'm going to hand you back over to Scott.
Thanks, Dave. Very good. Thank you for helping to put what we were going through before into some context for everyone. For those of you who are new to NetBrain and perhaps haven't seen our previous webinars or heard much about the product and what it can do, hopefully that helped to give you some context and some images and sort of extra to what I was running through before. If you obviously today's been on a particular use case, so if you have some interest on seeing how NetBrain can integrate and be presented within SolarWinds, if that's the place that you're coming from, or just further general information about NetBrain, of course you can view that on our YouTube channel, and I'll have the where to go for that shortly, so you'll be able to see that yourself. But for now, I wanted to give everyone a chance to ask any questions. If you haven't already been putting your questions in there and there's something you've been wanting to ask, then please feel free to do so. There are a couple of questions that we've got, so I'm going to pose those to Dave on your behalf and let him provide some answers for you. And obviously, if while we're doing that, you have questions that you want to ask and add to what I'm asking, please feel free to do that, and we will make sure we ask that if we have the time. If we get to a point where we have such a healthy question section, and bearing in mind we've got 25 minutes left, I imagine they'd have to fly through. But if we do get to that point, or if you come up with any questions you wish you'd asked after the point we've finished the webinar, feel free to send them through to myself, and we'll get back to you with an answer outside of the webinar. So first of all, Dave, first question for you. As we've sort of would anticipate with this sort of audience, and most likely from a customer of ours who is already using SolarWinds, first question we've received is, where does this fit in with my monitoring solution such as SolarWinds? Does it replace it or does it complement it?
Yeah, that's a really good question. So the easy answer is it complements it. And probably a really good analogy here would be, if you think about your kitchen, yeah, you've probably got a smoke detector. Yeah, so think of SolarWinds very much as your smoke detector. It's there, it's on all the time, and it's alerting you, if you like, 24/7 if there's any problems. So if you've got smoke, but it's not telling you where the smoke is actually coming from. It's just saying it's in the kitchen and you've got smoke. You've got a problem here. NetBrain, think of NetBrain as another device which actually is triggered in response to that, or maybe manually, like I was doing during the webinar, manually driven, where it actually goes, oh, what I'm going to do, I'm going to check the toaster. Is there any toast in the toaster? Any bread in the toaster? What's the temperature of the toaster? Is there anything on the hob? Yeah, is there a pan on the hob? Is the hob on? What about the oven? What's in the oven? Oh, I'll need to check the grill as well. So it's going around actually performing these checks, verifying exactly what the problem actually is, if you like, looking for the root cause of that. So this very much comes in, if you like, a nice little workflow in the real world, if you like, going back to SolarWinds, is if you think about this in a normal networking environment, SolarWinds highlights there's a problem. Yeah, I've got a network problem. I've got a big traffic spike or whatever. Yeah, and so I've got this problem, so how do I now fix it? You know there's a problem, but then typically without NetBrain, you'll fix this in a very manual way. You'll be getting your CLI commands out, you'll be SSHing to these devices, or perhaps using GUIs depending on this particular device. But with NetBrain will do that for you. Yes, you can drive it, and again, that could be a topic for another webinar. You could actually drive that yourself using things like runbooks or using preventative automation like these network intents. So hopefully I answered that well enough.
Absolutely. Just to further ask on that question, given today's example with failover and your analogy of the kitchen, are we effectively then, if I understand you correctly, and obviously you're substantially more technical than I am, but it may be that using SolarWinds as an example, if we saw, looking at SolarWinds, our monitoring system, that a number of devices, a large grouping of devices had gone offline behind a firewall, a router, that tells us that, you know, the fire alarm's going off, we have a problem. And whilst you can perhaps use that SolarWinds to try and troubleshoot what the root cause of that is by looking in down those different avenues, NetBrain with its preventative automation can not only help prevent that by checking those are in place, as we sort of said in my intro and throughout your demonstration, but also go through and make those checks to pinpoint this is the cause, the failover link has been changed by this configuration, changed by this person at this time, etc., etc. Would that be correct? Is that an okay example, or do you need to correct me there?
No, I think that's okay. I think that's an okay example. Yeah, I think that's fine. And it is. It's this ability to do this preventative automation, which is really powerful, and do these network intents, which you create very much. If you think about this, it's actually somebody's asked a question another question which I've just popped up. Is this scriptable? Well, a lot of the reason we do this is to prevent you having to do that. Yeah, so you don't need to resort to scripting and things like that. Is to try and remove that manual effort away, so you've got this single pane of glass. Having said that, there is a full RESTful API. So if you are a bit of a scripted junkie, that you can do quite a lot of what I've shown you, things like A to B paths and things like that, all via the REST, and even triggering the network intents themselves using scripts. If you want to, but using the RESTful API or using another system. So again, let's go back to SolarWinds. So the other thing you can do with SolarWinds is you can actually integrate the two. So if SolarWinds detects a problem, this is actually quite important. If SolarWinds detects a problem, SolarWinds can actually trigger NetBrain. So what we saw here during the demo, can I just quickly share my screen again?
Yeah, of course, yeah.
Let me just show my screen. So I'm going to make myself a presenter, and I'm going to show you my screen, which is this one here. So if you think about this during the demo, let's go back. Yeah, all of these, I was running these manually. Alternatively, you can actually run these using probes. But actually, what you could also do using the API is you can get a third-party system to trigger these. So this ties back to SolarWinds. SolarWinds can trigger this. So you can create it's an integration. You have to know your API stuff, but it's all documented on GitHub. But you could actually get SolarWinds to trigger NetBrain to do this.
And we have this, I think, in a previous webinar, which I've alluded to throughout the course of this webinar. And the next slide is on my presentation. I'll show you. We'll show it when we come to it. Is our YouTube channel. You probably don't need the link. You can search Prosper on Networks YouTube, and it will come up. But within that YouTube page, there is a previous webinar that we've done. I think there's a few that we've done on NetBrain, but there's a specific one where we detail how the two platforms can fit together, whether you're using SolarWinds to present the NetBrain data within it and then use that as a springboard through to the NetBrain platform, using SolarWinds to trigger that. And of course, further conversations about this can be had individually about your specific modules, use cases, with your account managers and people from both our side and NetBrain to see how that's going to work best for your platform, your deployment. So we've got a couple of questions here from one of my customers, Donovan. I suspect that this might be a couple of those questions where it's going to need to include involvement from both sides and maybe on an individual call, because the questions are relating to NetBrain in comparison to specific SolarWinds modules. So I'll pose them to you, Dave, but my guessing is that we're going to need, this is where we'd need to link up your NetBrain expertise with our expertise of SolarWinds so that they meet in the middle. So it's not to say that we can't answer, it's just that perhaps this call may not be the best juncture. So first of all, I'll pose them to you and you can confirm if I'm correct or you want to wade in. So with Network Traffic Analyzer, Network Configuration Manager, and NetPath, can NetBrain be considered a bolt-on? And the second question of a similar ilk is, what's the correlation between Network Configuration Manager and NetBrain?
Yeah, so again,
right?
one of the key differences here. So again, I would argue very much for, you are right, and I understand NetBrain in SolarWinds enough to at least have a stab. So the key thing here is, let's deal with the traffic and all of that stuff first of all, because that's an easy one to answer. So again, NetBrain is looking at the control plane. So NetBrain is control plane focused. What you could also do with NetBrain has quite a useful feature called single pane of glass, where you can actually talk to a third-party system. And again, we did a demo on this actually with Prosperon. Yep. So it can talk to SolarWinds and it can pull that information and it can display that on the maps. So you can see top talkers and that detailed, if you like, traffic information via SolarWinds. It'll talk to SolarWinds and grab that across. Okay, so that's the first thing. Also, again, with things like there was a module you mentioned, like the configuration manager and things like that.
Yes.
It's different. This is much more sophisticated because of the way you're doing network intents. So the network intents, if you like, they know what's good. You can define this is what's good. Yeah, and you can get very, very sophisticated. You can verify BGP neighbor relationships on all sorts of this was a very simple example because it was looking at things like changes and things like that. But actually, what if I need to verify certain things in my BGP tables and things like that? And that's where network intent can do things that these type of solutions really can't, because it's issuing commands, it's parsing, it's pulling the variables, it's comparing them to a golden baseline, and it's actually being able to determine what is good. And it's the same with the pathing as well. You can have a series of paths and say this is what is normal, this is the best path, and if this path fails over to a suboptimal path, notify somebody. So you can define that, you can define what is the best path, and it's looking in detail inside the devices. So and it's looking so again, there's different ways of doing pathing. NetBrain looks inside the devices themselves, and it's looking at their forwarding tables, how they are forwarding traffic, and if there's a firewall, how that firewall is handling that traffic.
Thank you, Dave. I think absolutely. You know, while I'm not disputing anything you said, I think just the key takeaway there for the person who asked that question is that, you know, there are many different ways to do this, many ways to skin a cat, as the horrible expression goes. And I think for anything like that, you're thinking along the right track, absolutely. But I would suggest, and I think we even have a call coming up, but I suggest that we sort of dig into those details on a more individual basis, and so we can look at your use cases, business objectives, obviously, which help form those network intents, and what modules you have on SolarWinds, if that's something you're looking to get to work together. Obviously, there are service management tools as well that come into that and perform part of the puzzle as well.
Yeah, and we certainly don't consider ourselves a replacement. We really don't. We consider ourselves complementary.
Yeah, absolutely. And of course, you know, as per my intro, being you know, a SolarWinds partner for so long, that's why we have this relationship. We firmly believe that sort of absolutely adds to your SolarWinds portfolio by adding NetBrain. So another question for you, Dave, what vendors does NetBrain support? Is it mainly Cisco, or do you support others such as Ariba and Fortinet? Ariba, sorry.
Oh, that's a nice easy one. We actually support a lot. let me just show, again, I can show you this. If I go here and I show
I was going
you.
to say, I think it's quite good you presenting your screen instead of me having my boring "do you have any questions" slide, because you get to
So if I
interactively
just go
answer
over
these.
here, let me just answer this over here. So if I go under this machine over here, this is quite a good one. Let me just log in. I can show you nice and easily. Oh, that's very good. And if I go in here, I can go in under tenant management, and I can show you here multi-vendor support, which is here. And actually, there's a help link as well, which has got this information. So as you can see here, lots and lots of different devices. So NetBrain has drivers for all of these different devices. And actually, they're in the back end, they're Python scripts, which go into these devices, issue commands, and pass the output of those commands using regular expressions. And actually, you can create your own if you really want to. Alternatively, NetBrain can create them for you. And so this is quite common if you have a customer with an unusual bit of networking equipment, and there are some really weird ones out there that I've never even heard of, and most people have never heard of. Then actually it's very easy for NetBrain to create a new driver for them. NetBrain can create them very easily by basically we give you a document and we say, please tell us what the relevant show commands are to get this information, and then show us what the output will be, and then NetBrain will create a driver based on that. It doesn't take very long at all. It typically only takes a few weeks. So we can add them. So literally hundreds of different types. And we also support lots of different types of modern equipment as well, such as Azure, ACI, AWS, etc.
Cool, thank you. Couple more. How easy is it to add support for new devices, firmware upgrades, and new vendors? I think you've probably touched a little bit on that just there.
It's
Yeah,
very
good.
easy. As long as it's got a CLI, then it's easy enough. We'll probably do an SNMP walk as well to get the MIBs, but again, it's as long as it's got a CLI, it's easy.
So here's a good one for you. Do you have a test environment that our customers can try for themselves?
Yes, I do. It's here actually. I'd anticipated that, or rather, I was going to show that at the end anyway, because this is really useful. And in fact, it's here. NetBrain test drive. Now, how do I actually share that on here? Is there a chat function that I can put this in?
Yes, there is a chat function. If you select who that's going to, and again, to any of the attendees who haven't yet asked questions, there should be a questions section and also a chat section. Either of those will pick it up, but Dave's now posted that in the chat for you.
There you go. So you've got that.
And I think our final question at the moment, obviously, if any more come in, we'll ask them. But you showed at the probe triggering a network intent. Is there any way to configure an external trigger to do the same thing? For example, if someone raises a ticket in ServiceNow, which then triggers NetBrain to run a network intent.
Yes, there is. So we actually, for ServiceNow, it's dead easy because we've got a ServiceNow app, we've got a NetBrain app within ServiceNow, but very much so. And in fact, I will finish this by showing you, I'll show you this. So if you go here, click the question mark, online help, and you go into the REST API. So our help is actually very, very extensive, and it's all here, RESTful API. And again, this is where, if we go in here, look, this is where we really do differentiate ourselves from a monitoring solution. Your monitoring solution tells you this is a problem, but typically you then go to actually troubleshoot that using manual tools, the CLI, the GUIs, all the different tools that you use, traceroute, packet, ping, all of that. NetBrain, the idea of NetBrain is you use NetBrain instead of those because it makes it a lot simpler and it gives you that visibility. That's where NetBrain comes in. And the maps, it creates the maps itself. Yeah, they're dynamic maps, which are, well, it can create them. You can create them yourself, or it can create them, and you can export them to things like Visio and stuff like that, and Word documents. But this is the RESTful API, and actually part of this is you can be triggered, called Trigger Diagnosis API. So you can trigger NetBrain using lots of different systems, including SolarWinds. Yeah, but there's quite a nice demo. It must be on YouTube or somewhere. I think it could even be me doing it, where we show how we can raise a ticket in ServiceNow, and at the moment the ticket is raised, it can call NetBrain. NetBrain can map paths. It can run commands. It can run network intents to actually do some diagnosis right at the time the ticket's created. So it's timely. You've got that information, if you like, that diagnosis right at the time the problems occurred. So, you know, sometimes with networking problems, they come and go, they change. But actually, with using trigger diagnosis, you can capture it right at the time the ticket is raised. So, yes. Is that okay?
Absolutely, yes. Thank you very much, Dave. Well, that's all the questions that I've seen come through. So we're doing pretty well. for time. I'll assume that if people haven't asked a question yet, if one doesn't pop up in the next couple of minutes, then that's all the questions we have. As I said before, please feel free to send questions through if you think of them after the presentation is finished. I've just got one more slide so you know where to find us. I've mentioned many times throughout this that you can find us on YouTube, so you've got the details there if you want to. That's got a number of other webinars on SolarWinds, NetBrain, other products and other features of those products. So if you go on there and search as you normally would, then you'll be able to find some free help there. And this webinar will be posted there shortly as well. So if you have any colleagues that weren't able to join today, or you'd like to refer back to this, then absolutely you'll be able to find that there. And of course, you can see our website, LinkedIn, and our Twitter channel as well. Aside from that, though, that's it for our presentation today. So I hope you found it helpful. Obviously, you've got the test run there from Dave as well. You know where to find us. If you have any questions, send them through. But aside from that, I will let you go and bid you farewell and a good day and speak to you soon. Bye-bye.
Thanks, folks.
Thanks, Dave. Bye-bye.